Welcome to the channel. Our today's subject of discussion is speedometer cable, quality check test, and installation of league assembly instructions. The discussion will include Amstrad testing, key and holding strength, and a pull-off load test. The topics included are visual inspection of speedometer cable, its dimensional check, flexibility test, torque test, lubrication check, connection integrity test, end play test, and road test, tensile strength test, installation of speedometer cable with speedometer, and other tests including ancillary testing, key and holding strength, and a pull-off load test, and finally, introduction to the next topic. Coming to visual inspection, the objective of visual inspection is to identify any visible defect or wear that could affect cable performance. The method include inspect the entire length of the cable for any fraying or broken strands, kinks or sharp bends, cracks or damage to the outer casing, wear or corrosion at the connection points. The acceptance criteria for visual inspection is that no visible damage or wear is observed and outer casing is intact and flexible. Number 2. Dimensional check. For example, outer casing outside diameter, inner wire or inner cable diameter, overall cable length, protection location check, and other important dimensional checks. The acceptance criteria is that all the dimensions to be checked must be acceptable against the OEM standards. Details in this regard will be discussed in another video, that is production of control cables for automobiles, motorcycles, scooters, and auto rickshaws. Number 3. Flexible test. The objective of flexible test is to ensure that the cable maintains flexibility without binding or resistance. Its method is lay the cable flat and attempt to bend it in various directions. Ensure that bends have a minimum radius of 150 millimeter or say 6 inches. Check for any stiffness or binding during bending. The acceptance criteria includes cable bends smoothly without resistance and no binding or stiffness is observed. Number 4. Torque test. The objective of torque test is to verify that the cable can transmit rotational force without slipping or binding. Method: secure one end of the cable and rotate the other end by hand. Measure the force required to rotate the cable and check for smoothness. Acceptance criteria will be: it has smooth rotation without jerks or binding, and no slipping or excessive resistance is observed. Number 5. Lubrication check. The objective of lubrication check is to ensure proper lubrication to reduce friction and wear. The method to check is: inspect the inner cable or inner wire for adequate lubrication. Apply a small amount of grease, such as shell grease, if necessary. Acceptance criteria: inner cable is adequately lubricated. No excess grease that would attract dirt. Number 6. Connection integrity test. The objective of connection integrity test is to ensure secure and proper connections at both ends of the cable. The method is: inspect the square ends of the cable for wear or rounding. Check that connectors are secure and free from corrosion. The acceptance criteria for this test is: square ends intact without wear, secure and clean connectors are observed. Number 7. End play test. The objective of end play test is to verify that the cable ends engage properly without excessive movement. The method to test is: rotate one end of the cable and observe the other end for movement. Ensure the inner cable rotates without excessive play. Acceptance criteria is: inner cable rotates smoothly without excessive end play. Number 8. Road test. The objective of a road test is to confirm the cable performance under actual driving conditions. Install the cable and connect it to the speedometer. Drive the vehicle at various speeds and observe the speedometer's response. The acceptance criteria includes: speedometer needle responds smoothly and accurately. No erratic movement or failure is observed to register speed. So far, the number of tests, the total number of tests we have discussed are: visual inspection to detect visible defects or wear, dimensional check to verify and check dimensional accuracy, flexibility test to ensure cable maintains flexibility, torque test to verify cable transmits rotational force, lubrication check to ensure proper lubrication, connection integrity test to confirm secure and proper connections, end play test verify proper engagement of cable ends, and finally the road test to confirm performance under actual conditions. Now coming to the tensile strength of a speedometer cable. To assess the tensile strength of speedometer cable, which is typically a mechanical flexible cable designed to transmit rotational movements from the vehicle's drivetrain to the analog speedometer, you can follow the steps. That is, number one, sample preparation. Cut a representative sample of cable, typically between 100 mm and 200 mm in length. Allow the sample to accumulate to standard laboratory conditions, that is 23 degrees centigrade and 50 degree centigrade, 50% relative humidity, for at least 24 hours to ensure consistent result. Thereafter, secure clamps both ends of the cable sample into the grips of the universal testing machine and ensure that the grips are appropriate for the cable's diameter and construction to prevent slippage or premature failure. Verify that the cable is aligned along the axis of the testing machine to ensure straight pull and accurate measurements. Then configure the tensile machine to apply a constant tensile load at a specified rate. That is typically between 10 millimeter per minute to say 100 millimeter per minute, depending on the cable material's properties. Gradually increase the tensile load until the cable reaches its breaking point. Continuously monitor the force applied and elongation of the cable. Thereafter, record the maximum force in newtons the cable withstands before breaking. This value represents its ultimate tensile strength. Measure the elongation at break, which is the percentage increase in the length from the original length before failure. Calculate the tensile strength using the following formula, that is tensile strength is equal to maximum force divided by original cross-sectional area of the cable. This will provide the tensile strength in units of force per unit area, that is Newton per millimeter square. Compare the obtained values with the industry standards or manufacturer specifications to assess the cable performance. The cable should withstand a minimum tensile force as specified by the manufacturer or industry standards. The cable should exhibit a certain percentage of elongation before breaking, indicating ductility and flexibility. The recommended equipment are universal testing machines. The machine goes from Instron or any other brand machine suitable for conducting tensile tests on the cables, equipped with extensometer for precision measurement of elongation. Here is sample data table. Maximum force the recorded was 350 Newton. Elongation at break point 12% and the tensile strength as 35 Newton per millimeter square. Now coming to installation of speedometer cable with speedometer. Here are the key points to follow to prevent malfunctioning of the speedometer and breakage of speedometer cable, especially the inner wire. Number 1. Assembly routing should be as per OEM's manual or instructions. Number 2. Nut should be locked as per instruction while following the process sheet of OEM. Free length should not be too long. Burrs must be removed while cutting outer casing. Speedometer quality must be ensured. Transfer gear quality must be ensured. The material quality must be as per OEM standards. Ensure that the speedometer is not very stiff and is not creating too much resistance, resulting in the breakage of speedometer cable. The cable should not be fitted with too many bends, and the bends should not be too sharp. This is very, very important. In an ideal application, the cable should be fixed in such a way that the minimum radius of any bend is not less than 6 inches, and that there is no bend starting less than 6 inches from either end. Inner wire must be greased using good quality lithium molybdenum disulfide grease. Dry and dusty wires are prone to rust and thereafter resulting in breakage. Use good quality anti-rust oil to prevent rust on the inner wire. These four conditions 9, 10, 11, and 12 are the most important for installation of speedometer cable with speedometer. Now coming to ancillary testing of speedometer cable and thereafter including key, key and holding strength, and cap holding strength. For example, the standard in case of key and holding strength is 30 kg minimum, and cap holding strength is 25 kg minimum. This is on the assumption basis. To check key and holding strength of a speedometer cable using Amsler testing machine, the test must be adapted to measure pull-off or tensile force required to separate the inner wire from the key end. This test does not use the machine in its rotating fatigue mode, but rather leverages its tensile testing capability. And the objective of the test is to determine the axial tensile strength, that is pull-out force of the key end joint, that is how strongly the key end is crimped or welded or fitted to the inner cable wire. Take the inner cable with key end, nipple, crimped or fixed, cut to appropriate length, that is 200 millimeter or 300 millimeter, and then one end is fixed in a lower grip, usually a V-jaw or chuck, designed to hold square or hacksaw ends. The opposite end cable is gripped in the upper grip of the tensile tester or vice versa. Ensure that the cable is aligned axially, no bending or side load. Test should be done in tension only, not torsion. The machine applies a gradual upward tensile load at a constant rate, that is say 10 millimeter per minute, or as per specification. The load is increased until the key end pulls off, or the cable breaks, or the maximum load is reached without failure, that is the pass condition. Data is recorded, peak load in Newton or kgf at which the key end detaches or cable fails. Mode of failures could be pull out of key end or crimp failure. It could be wire breakage. It could be slippage. Elongation or extension, if it is there or needed, it should also be recorded. Acceptance criteria for the test is, it depends on OEM or internal specification, but typically minimum pull-off load, say, should be greater or equal than 100 Newton or as per design requirements. No slippage threshold. Break should occur in the wire, not at crimp. That is the ideal case. It is critical as the key end transmits rotation to the speedometer. If it fails or slips, speedometer reads erratically, false mileage is recorded, and there could be complete functional failure. The Amsler testing machine, which we have mentioned, This machine was invented by the Swiss engineer Amsler Lefon. He was a mathematician, physicist, and inventor who was best known for his contribution to mechanical measuring instruments. He founded the company J. Amsler and Company in Switzerland, which became a pioneer in the field of material testing machines. In 1854, Jacob Amsler invented the polar planimeter, an instrument for measuring the area of irregular shapes. Later, he applied his expertise in mechanics to invent mechanical testing machines to measure tensile strength, compression strength, bending strength, and fatigue strength. One of the significant contributions was the development of universal testing machine with integrated recording mechanism, analog dial or chart base, which evolved into what became finally known as Amsler testing machine. In automotive, the Amsler testing machine is useful for a lot of applications, including wires and cable, springs, shaft, speedometer cables, and so on and so forth. Amsler machines were widely used in Europe and Asia throughout the 20th century, were known for its durability, precision, and mechanical design even before digital control systems were introduced. Amsler work, the engineer worked, laid the foundation for modern servo hydraulics and electronic testing machines. Now coming to pull-off load testing machine. A pull-off load testing machine, sometimes called a tensile or axial load tester, is a device used to apply a control axial, that is pulling force, to a component to evaluate its mechanical integrity, bond strength, or retention capability. It measures the maximum force required to separate two connected parts or to break a part under tension. Its application to speedometer cable. A speedometer cable is a flexible mechanical cable, usually spirally wound steel, that transmits the rotational motion from the vehicle's gearbox to the speedometer gauge. The pull-off test for the speedometer cable is used to evaluate mechanical strength and durability of cable core to connector crimp strength, outer casing to fitting anchorage, connector retention strength, that is ability to withstand pulling force during installation or service conditions. It is important to ensure durability. It prevents failure to vibration, thermal expansion, or operator mishandling. Validates assembly quality, that is, detects poor crimping, adhesive failure, or loose fittings. It conforms to OEM quality standards required during production validation and supplier audits. It is important for safety compliance, prevents detachment under high load or stress, which could affect speed signal accuracy. Typical test parameter could include, say, full load applied 100 to 300 newtons as per OEM specs, rate of load increase that is 10 newtons per second, and acceptance criteria is no detachment, no permanent deformation below threshold. Test scenarios. Initial product validation. New Speedo cable assemblies tested before market launch. For batch quality testing, that is random sampling from production lots. Endurance after vibration or thermal cycling. Evaluate pull-off after simulated environmental stress. Example, a motorcycle speedometer cable is crimped to its end fitting. A pull-off load test applies tension to simulate the force it might experience during aggressive riding or maintenance. The test ensures that the cable does not detach below a force of, say, 250 newtons, validating its reliability. With this, we conclude our today's discussion on this subject. Please do drop your comments and share your experience to improve the contents of this channel. Our next topic of discussion would be, in this respect of speedometer would be weather resistance or weather sealing test. Thank you and thank you very much.